is charged to Q0 is connected to a coil of self-inductance L. Find the time after which energy is stored equally between capacitor and inductor. Suppose you have a capacitor now. It is fully charged. Its capacity, its charge is Q0, capacitance is C. Then you know that energy stored in the capacitor is Q0 square divided by 2C, or half CV square. When this is connected to an inductor, what happens? Slowly the energy of the inductor increases. So energy of the inductor, let's say energy in the capacitor, energy of the inductor is half L I square. So when energy of the capacitor is equal to energy of the inductor, what happens is energy is equally shared. So the total initial energy is Q0 square by 2C. Then by the time half of the energy goes here, energy of the capacitor, when energy of the capacitor equal to energy of the inductor, that time energy of the capacitor is going to be half of the original energy, Q0 square divided by 2C. So that is equal to Q0 square divided by 4C, that is the energy. By the time half of the energy is stored here, let's say the charge on the capacitor plate is reduced to Q. So at that instant, energy of the capacitor is Q square divided by 2C. When you compare these two, we know that Q is equal to Q0 divided by Q square is equal to Q0 square by 2, or Q is equal to Q0 by root 2. That means by the time half of the energy is shared by inductor, charge reduces from Q0 to Q. That Q value will be original Q value by root 2. We have discussed in the previous video that charge on the capacitor plate at any instant Q will be equal to Q0 cos omega t. Here Q is equal to Q0 by root 2, and Q0 is Q0 cos omega. Omega is 2 pi by time period into t. When you cancel these two, we know that you don't need to substitute these things also. So let's keep it this way, cos omega t. So when you cancel these two, you get cos omega t equal to 1 by root 2, or cos omega t equal to cos of 45 degree pi by 4, omega t equal to pi by 4, t equal to pi by 4 omega. So the time after which these two have the same energy, t equal to pi by 4 omega, where omega stands for the frequency of the LC circuit, which is, we already know that omega is 1 by root over LC. So pi, so the time t equal to pi by 4 into 1 by root over LC. So pi by 4 into root over LC. The time after which these two have the same energy will be equal to pi by 4 into root over LC.